This is the lesson for Handout B. So take a look at our first problem here. We've got a inequality that we're going to end up trying to solve. So when we solve inequalities, what we want to do is we want to isolate the variable. But before we can do that, we need to eliminate some of these parentheses. So that's what we're going to end up doing first. And so when we do this, I'm going to take this positive 2 right here, and I'm going to distribute it over that subtraction. Same thing here with this negative 5. I'm going to distribute it over this subtraction. So here's what we've got now. We bring down our 4 plus 4. 2 times 2 made the 4. Minus 16y greater than or equal to, bring down the 3, and then distribute the negative 5, so it makes negative 45, plus, watch the sign there, negative and a negative make a positive 10y. So I go ahead and collect some like terms. So these two terms right here are going to combine as 1, and then these two terms are going to combine as 1. So let's go ahead and rewrite what we've got now. That makes an 8 minus 16y greater than or equal to, subtract these two numbers, we get 42, and it's negative because there's more negatives than positives, plus the 10y. So we go ahead and move some terms around now. Maybe we'll end up subtracting this, or adding this 16y to both sides. That might be what some people end up doing. And here I would have to add the 42 to both sides. So when I do this, I now have a 50 is greater than or equal to, and this makes 26y. And so from this point, what I need to do is divide by that 26, and we'll have our answer. And so there's only a common factor between these two terms. 26 doesn't quite go in there evenly, so I'll just take out that 2 that goes into both these numbers, and now I've got 25 over 13 is greater than or equal to y. Now, typically you're not going to see an answer this way. We more or less like to see it with y first. And so notice that the inequality sign points to the y. So if I turn it around, I've got to have the y, or the inequality sign still pointing to the y. So y is less than or equal to 25/13. Taking a look at our next one here, we've got find x and y intercepts. So when we want to do that, we want to set each of the values equal to 0. So if we set x equal to 0, this is going to give us our y-intercept. So now we've got 1/2 y equals 6. And then we can go ahead and solve by just doing an opposite operation. I'm going to multiply by 2 on both sides. That'll cancel out the 2's here, so I'm left with this y equals 12. So that is the y-intercept. And you could write it this way, or you could end up writing it as 0, 12. And for the next part, I need to end up setting y equal to 0 to find the x-intercept. So I have now 6x equals 6, and then I can do an opposite operation. I can divide by 6 on both sides. And so when I do that, I have x is 1. So you can see their answer is x is 1, or you could see it as 1, 0. And so either of those answers would end up working. So in this one, they're asking us to graph. Now, typically whenever I have x and y on the same side, I would graph using xy intercepts. And that's what I'm going to end up doing here. So I'm going to take that 3x, set it equal to 15, do the division, and when I divide by 3, I end up with x at 5. So go over 5 spaces, 1, 2, 3, 4, 5. Notice I'm on the x-axis here when I did that. Then I do the next one, negative 5y equals 15. Divide by negative 5, and when we do that, we have y at negative 3. So I go down 3 spaces, 1, 2, 3 on the y-axis, and then I've got 2 points in which I can draw a line between. Looking at our next problem here, this is slope-intercept form. Here's my y-intercept, and then my slope is the 3. So I'll deal with that in just a minute. Let's plot the y-intercept first, so down 2 spaces on the y-axis. Now treat that slope as a fraction, 3 to 1. That means you're going to go in the y direction 3 spaces, 1, 2, 3, x direction 1 space. And the nice thing about the slope-intercept form, it gives you lots of points. You can also go the other way, down 3, left 1, gets you on that same line. And then you can draw a line between those points. Looking at our next one, I would go ahead and solve for the slope-intercept form on this one. I'm going to go ahead and subtract that 2x from both sides. So when I do that, now I've got y is less than or equal to, see how it points to the y, less than or equal to negative 2x plus 3. So I'm going to start with the positive 3, that's my y-intercept, and then just go down 2, right 1, down 2, right 1. Now, after I do that a few times, I can draw a line, but be careful in the type of line you draw. Look at the inequality sign. It's equal to, so that does mean a solid line. That means the points on the line are solutions. But the solutions can also go either above the line or below the line. So in this case, y is less. Less means smaller. So the y values that are solutions are less than the line. So less means below the line. And so that would be our answer here, down in this region. So the shading represents the region that the solutions are. Next one is asking us to determine whether the point lies on the line. Well, you're just going to take your x value, which is 6, put that in for x. Take the y value, which is 18, put that in for y, and see what happens. So now we've got 2/3 times by 6 over 1, and then equals 1/3 times by y, which is 18. It's 18 over 1. And then this is a minus 2. So I go ahead and do some opposite operations. Actually, in this case, before I do any of that stuff, let's do some reducing. 3 goes into 6 2 times. Multiply across, and we've got 4. This side, 3 goes into 18 6 times. And then I just do 6 minus 2, which is 4. So when the two numbers do agree, that means yes, the point is on the line. Well, let's take a look at our next one. Here it's asking for writing a linear equation. On the next problem, we're asked to write a linear equation using point slope. So what we're going to do is, first of all, we're going to write down our point slope formula. Y minus y1 equals m times x minus x1. So we go ahead and substitute. So we've got our x value here and our y value. And actually, these are going to go in for the x1 and the y1 values. Our slope in for m. So let's rewrite what we've got. Y minus 2 equals the slope, which is 1/5, times by x minus negative 5. So anytime you see a minus negative, treat that as a plus positive and distribute that 1/5 over that sum. So here's what we have now. We've got a y minus 2 equals, and then we've got 1/5 x, and then plus 1. 1/5 of 5 just makes 1. The 5's cross cancel, you're left with 1. So from this point, we can go ahead and add the 2 to both sides. And so when I do that, I have 1 and 2 make 3. So now I've got y equals 1/5 x plus 3, and that would be my answer. Oops. So let's go ahead and box that again. So we take a look at our next one. Now in these problems, when you have more than 2 points, what we can do is cross off one of those points. So let's cross off this one here, and we need to find the slope first. So our slope formula goes this way. M equals y minus y1 over x minus x1. So we go ahead and take our y values. Let's start with these numbers here, 5 and 3. So 5 minus 3. And then down below, we've got our x values, negative 2 and 2. So we'll start with the negative 2 minus positive 2. Now notice I started with the 5, so that means that I need to start with the negative 2. And I go ahead and do some work, and I subtract these numbers. I end up with 2 over negative 4, which reduces down to negative 1/2. Notice there's only one negative, so it is a negative slope. So from this point, we can go ahead and write our point slope formula out and substitute some numbers in. So I'm going to take this 3 and 2. So the 2 comma 3, this point here, I'm going to use that point and my slope right here in that point slope formula. So y minus 3 equals negative 1/2 times by x minus 2. And so I can go ahead and distribute that negative 1/2 over this difference. So now I've got y minus 3 equals negative 1/2 x plus 1. Negative 1/2 times by negative 2 makes positive 1. So from that point, all I have to do is add that 3 to both sides. So I'm adding the 3 to the 1, and that gives me 4. So my answer is this, y equals negative 1/2 x plus 4. That would be my answer. Well, looking at the next one, it says find the perpendicular slope. And so perpendicular, remember this means the slope needs to be the opposite and reciprocal. So we need opposite sine and reciprocal. So those are the two criteria for perpendicular slope. So first thing is to find the slope. So I need to subtract that 3x from all sides. And so now I've got this 5y equals negative 3x plus 2. Well, the next step is to divide by 5. So when I divide by 5, we end up with a y equals negative 3/5 x plus 2/5. So that means this is my slope of the line that I have. So the slope equals negative 3/5. Well, that means the perpendicular slope is going to be exactly opposite and reciprocal. So opposite sign would be a positive. So it's going to be a positive, and reciprocal is going to be 5/3. So that's what my perpendicular slope is. And here's my symbol for perpendicular, just a T. And so that would be upside down T, that is, would be 5/3. Well, the next problem asks us to find a parallel slope. Parallel slope means the same slope. So whatever the slope is exactly the same. So again, the first thing is to find out what the slope is. So you need to get y by itself. Negative 5y equals negative 2x plus 6. So from that point, all you're doing is dividing by negative 5. And when you do this, you end up with y equals, and then you do some reducing here. So we have 2/5 x. See, the negative signs cancel. That's why I did that reducing. And then minus 6/5. Well, we don't worry about the negative 6/5. We're just concerned with the slope. The slope is 2/5. So the slope here is 2/5. The parallel slope, here's my symbol for parallel. Parallel slope is exactly the same, 2/5. So that's what we'd have. Well, those are problems that you'll see on Handout B. Good luck.